You are listening to the MER-Mates podcast, the marine science research podcast.
Did you know that your waterproof raincoat could end up in the Arctic? Although this might sound odd, today's guest will explain to us about the chemicals our daily products are made of and their environmental implications. And what is life like in a research vessel? She will also be giving us some insights about this.
We will also be hearing about how spreading the science for all the public is an important part of her career.
Okay, Sam, so we won't extend too much on the introduction and we can focus on our first interview. Do you mind introducing our first guest?
Yes, I would love to. So today we have, as a guest, a researcher from PI. She has been from Argentina to Canada to even Murcia. She's basically been all over the place. She achieved a PhD, Occurrence, Transport and Fate of POPs in the Global Ocean, well, POPs, with the University of Barcelona, and she's currently a postdoc researcher dealing with marine xenobiotics in the marine environment. Not only this, but she also is working on science divulgation. We will hear more from that later on. So we're glad to have with us here Belén González Gaya. Welcome.
Hi guys, thanks for having me here.
So we would just like to start to know a little bit more about yourself, because you're a postdoc researcher, and we're very curious to know, what is your day-to-day like?
Well, I have to say that I'm like a postdoc. So this is my 10th year as a postdoc already. And yeah, now like I'm more into teaching and supervising students more than directly being in the lab. Even if every day, of course, you need to do some supervision or go and work with your students. But yeah, I'm starting to get into the office work more and more every day.
Right, so you're supervising mostly now?
Yes, yeah. At the moment, I have like every year between, let's say, 5 and 8 students, depending on bachelor or master thesis, or also some PhDs. But yeah, normally I do more like supervision than direct work, lab work myself.
Now it looks like you are more established here, but in the past you've been moving in different countries or in the same country but different provinces. For a new researcher or for future researchers, do you think the fact that you have to move is something that they should expect in their career? Or?
Yeah, I think that is super enriching. Like, it's really, really different the way that every lab or every center, every university works. So I think that it's a great opportunity if you can travel around, if you can meet different, not only researchers, but also the way of science is performing is not the same in the US or in Canada than the one done maybe in Europe. And of course, in different countries from Europe can be super different as well. And that is super enriching. First of all, because you meet new people, because you meet new countries. You guys know, like in the MER environment, for instance, it's great to travel around. But also only because of the logistics or the way that science itself is perceived, it feels just different.
Does it go like integrated into like a researcher? So if someone wants to become a researcher, one of our listeners, should they expect having to move a lot?
Well, at the moment, if you really want to get established as a researcher at least in a public organization like a university or research center in Europe, I would say that it's compulsory, because most of like competitive calls or grants, fellowships, you need to be moving from one country to another. There are also like rewards, like if you want to come back to your country of origin, then you have to be outside maybe 2 years, or there is a lot of mobility grants. So maybe it's not like compulsory, but like mostly, let's say 80% of the works that you can apply at first instance are going to request that.
Yeah, I think also it's important to move, especially when you are young, because maybe you have less links with your country, but at some point you will also have to establish in somewhere, not at least.
Yeah, but you never know where. Like, I'm originally from Madrid, and my family comes from Murcia, so it's one of the coolest places to be. But yeah, I would have maybe seen my future me at that moment maybe coming back, but then you never know. So like now at this moment, I would really love to stay in the Basque Country. Like it's an awesome place. It has everything I always wanted, like from the seaside to the mountain. The PA is great. The university is really cool. So yeah, you never know. I think that if you have a researcher inside, there is always this curiosity, this motion that moves you around, and that can that can transport you to another future that you never thought you had. So yeah, you never know.
Well, you, yourself, as we are talking about, you've moved quite a lot. You've been in Canada, you've been in Argentina, you've been in Spain, and
Italy too.
in Italy too. Oh, you're right, in the Stazione Zoologica Antondon. Can you tell us maybe a valuable lesson you've learned from all these moving around, or maybe a place that really marked you?
Well, place, I think that all of them mark you a little bit, right? Like every learning is different. Like it's not the same, of course, living in Toronto that living in Naples. I don't know if you have been in there, but they are absolutely opposite. Yeah, I guess that from every single country or every single lab, you can get a lot. Like, yeah, for instance, in Argentina, I would get like they had nothing. Like the lab was very well. I was working in the Science Museum of Buenos Aires, and they had it was ecology lab, and they had almost nothing. Like they were doing basic taxonomy or really rough identifications, biodiversity using very easy indexes, but at the same time there was everything to discover there. Like when I was there, and it was only for like 8 months, we discovered a new variety of one mussel. And I mean, it was like a group of students just going on a beach that was in the middle of nothing, but it was in the province of Buenos Aires. So it was not like even Patagonia. And so I think that in general, the places where they have a lot of resources, or at least that's my experience so far, they go very deep into everything because they know more. But in the places where you have less resources, you have a lot to discover. The point is like maybe from everywhere where you go, you can learn something new or enjoy the way they do things, even if they are so different, right?
Interesting. You talked about one end of the spectrum being a place with not many resources in Argentina, which would be maybe the opposite, a place in which you had absolutely everything available.
Wageningen. It's a university where I did my master's in the Netherlands. It's one of the biggest universities in Europe, actually. Is devoted to agriculture and environmental sciences. And it's super high in the Shanghai's ranking. It's multidisciplinary, like people working all over the planet with all different kinds of labs. There, I was amazed. Like you went on a lab and you had your own place, your own computer, your own everything. So you had even your own micropipettes for you, like.
Well, that is quite amazing.
Yeah, it was super amazing, yeah.
Although right now, currently, you're mostly supervising, what would you say is your current research about? What are the topics you're working with?
Well, in the analytical chemistry department I work in, it's, as you mentioned at the beginning, we do a lot of research on organic pollutants. We work with, our analytical instruments are spectrometry, so we work with polar pollutants, but also non-polar. So we had projects with antibiotics and antibiotics resistance. We have projects with pharmaceutical products in the environment. Also, we are analyzing drinking waters, or for instance, for perfluorinated compounds. I love these chemicals. They were part of my thesis, and like they are super interesting for me. Yeah, I'm a bit the odd one out maybe in the analytical chemistry group because I come from a more biological or ecological background. So I'm trying to implement also a lot of bioassays within our workflows. So yeah, it's a lot of different things at the same time, I have to say.
You mentioned the organic pollutants, and we know the persistent pollutants. Can you explain more about them?
Yeah, look, among all the organic pollutants, so basically formed by carbon and hydrogen, we have some that are like cataloged as persistent because they have three main characteristics. So they are very resilient. They are very difficult to degrade, so that's why they are called persistent. They are bioaccumulative. So once that they are released in the environment, they tend to stay in the organisms, or they are acquired in the organisms. As they cannot be metabolized, they are really transported even along the trophic chains, so they are biomagnifiable as well. Third is that all these persistent and bioaccumulative pollutants, they are most likely to be toxic as well. So when we join these three characteristics together, we have like the named POPs, so POPs, persistent organic pollutants, and those are regulated by the Stockholm Convention. So those are, it all started with a dozen. They were called the Dirty Dozen, like the Far West film. And now there is a list of almost 20, I think, or 20 something. And actually the PFAS that I said before that I loved, there are a big queue for being candidates of the new list on the Stockholm Convention.
Regarding that legislation, there are a lot of compounds which we use in the daily basis, and we can find them in cosmetics, in the clothes, in whatever. From the time that you discover they are toxic to they get banned, it takes a lot of time. And also, if they modify it slightly, the structure, it would be, again, let's say, legal. Regarding that, what's your main concern?
Yeah, the thing is that in general, I don't know if what comes first, if the ubiquitous occurrence, so that they are detected all over, and then we start thinking, okay, this is all over, maybe we should worry, or if it's the toxic analysis, because actually there are many chemicals that we know that we can find them in, for instance, in every effluent of wastewater treatment plant in Europe, let's say, and we don't have clear values for or toxicity thresholds, let's say. So they have not been properly tested at environmental relevant concentrations. So maybe you have, let's give an example, like you have thresholds for aspirin at lab working concentrations, or for when you take those pills or those pharmaceuticals or those cosmetics, they have been tested for human use, but they have not tested as a cocktail in the environment. So yeah, my main concern would say maybe first implementing proper monitoring programs, which are lacking in more than 2/3 of the world, I think. But also to figure out if all these substances at the same time, so look like the cocktail effect, right? Like if that chronic long exposure of hundreds of tons of chemicals is going to be harmful for us or for the environment or not. That would be maybe the main idea behind of all of us, for instance, working in PA.
PCBs, right? The ones you said are your favourite.
No, I say
Did I get that wrong?
PFAs.
PFAs. Could you get a little bit more into them?
Yeah, like it's perfluorinated substances, perfluoroalkylated substances.
Okay. I must say my chemistry is not the best.
It's okay. No, those are chemicals that have, the polyfluorinated substances are that they have a lot of fluorine in the molecule, in the structure. And perfluorinated means that all the hydrogens are substituted by fluorine. So I don't know if you are aware, but the fluorine carbon is the strongest bond in organic molecules in the planet. So once that you start with a lot of fluorine, organic molecule is very, very difficult to break. Okay, so that's why they are called to be, because once that they are synthesized, they cannot be degraded by any bacteria or by metabolism that we know so far. There are some transformations and biotransformations because you see them quite properly. They ionize very nicely, and also because they are a great proxy of global transport. That was always my main research in the past, and maybe now I'm more into local projects, but I also would like to go back to global transport, because of course I'm always like amazed by the possibility that a person in Greenland that has never used a pesticide, even has never seen a crop in their life, they have pesticides in their breast milk. So that was an image that I got in my first year of degree in environmental sciences in Madrid, and I could never remove that image from my head. So with PFAS, it happens that like you produce it, and then what happens with it? It will go to Antarctica. It will go to Mount Everest. It will go wherever. So why is going there? How is transporting? And what is going to do there?
So PFAS are pesticides?
No, PFAS, like the regulated ones, the ones included in the Stockholm Convention. So it's any pollutant that has a lot of fluorine in their structure. Okay? Like PFOA and PFOS, those are mainly like end products from different industrial or day life materials. Let's say Gore-Tex, Teflon, any substance and any surface that has like antifouling or anti-water repellent, for instance, waterproof clothes had a lot of PFAS. So yeah, and actually they are super interesting because they have great like applications. So most of your pants, most of your raincoats, most of your boots for going to the mountain have PFAS. But so they are really useful, but at the same time we need to avoid them because now we are discovering that they are not that good for the environment. So yeah, it's a kind of tricky. How should we proceed?
It is quite tricky because you just mentioned raincoat. I think my raincoat is Gore-Tex, so probably it's filled up with PFAS.
Yeah, probably it is. Yeah, I have to say that they kind of like the industrial treatment in the surfaces is quite good. So if you use your waterproof clothing or your pants on a proper way, it's okay. But you always need to replace them when you start seeing that they are getting old or damaged and so on. And of course, the best option would be not using them. But yeah, it is true that they have been used for a very long time for being banned in applications such as popcorn, like the bags that popcorn you put in the microwave, the inner part, it was like for not getting them stick into the paper. So it was full of fluorinated compounds. And we were eating those popcorn like crazies. So it is like any chemical, any new substance. Like you discover it, you see that their properties are great, and then you use it like crazy, but then you realize that it hasn't been tested enough.
Talking about the fact that you want to maybe go back to a global transport of maybe global circulation. I guess that's a little bit also how you started.
Yeah, exactly. Like when I did my PhD, it was because, of course, I loved the topic. So I saw an ad in the CSIC. It was in one of the research centers of CSIC in Barcelona. And I saw that it was in this awesome circumnavigation around the globe on a boat. I love sailing. Of course, I really applied for this PhD. And when I got it, I had to admit that it was the most precious gift I could be given. So that's why I also want to come back to that because it's my main dream, let's say. Like since I started my science degree, I really wanted to guess on that. So, and of course, in my PhD, I did a lot of perfluorinated substances in the open ocean, and we could find them all over.
Quite impressive.
Yeah.
I thought it would maybe be more limited to coastal waters, where like near the source of the pollution.
No. In for instance, in the South Atlantic Ocean, there was a lot. Actually, up to date, there's still a clear reason why. Brazil is mostly blamed for these very high peaks of perfluorinated substances in the Southern Atlantic basin, and it's because they have some exemption for the Stockholm Convention. They can use sulfuronamide, which is a pesticide based on fluorinated chemicals, and apparently is the only pesticide that can kill the fire ant, which is really damaging a lot of crops in South Brazil. That's why they are allowed to use it, but at the same time, we should think, okay, but why there is a lot of these ants in South Brazil? Because before it was a forest, and now they are growing soja. But coming back to the ocean, yeah, you can find PFAS all over. One of the last papers was in the Himalayas, and due to the strong tourism pressure that is going on there are a lot. There is in the North Pole, there is in Antarctica, so yeah, you can find it all over.
Can you find those PFAS in those remote regions? How do you work backwards and trying to find the source of that? Because in some cases it's easy, but in others it might be more difficult to find the guilty, let's say.
Yeah, that's really, really difficult. And of course, it depends on how remote you are. Like, for instance, When you are talking about atmospheric pollution, there are some models. Like there is a very known and used model from NOAA called back trajectories. So you can use it for trace back where the air that you are sampling comes from. It has kind of big error, let's say, but of course it's a meteorological model. So it's like if you know that it's going to rain in 3 days, you know where this air mass is going, right? The problem is, of course, tracing back in terms of years time or decades time. That's not possible. Well, that would be possible maybe if you're analyzing cores or ice cores or sediment cores, but I haven't done that yet. Regarding water masses, there are some isotopic profiling, so you could eventually know how old is the water mass that you are sampling or where it may come from according to some currents. But yeah, those global models are really, really complicated. Yeah.
You've also been recently in another cruise expedition, have you?
Yeah, I was super lucky. I was invited to go to Antarctica. I thought that I wouldn't make it so far because when I did my PhD, I was in a polar working group and I was the only one doing tropical areas. So I was, again, the odd one out. But I thought I had missed my chance, fortunately. And actually, thanks to MER, we are collaborating a lot with the University of Bordeaux and working with a researcher from there that he's really into Antarctic expeditions. Well, he got a empty place just by chance last year, and he offered me this position. So yeah, I was for 15 days traveling to the Weddell-Ross, so into the Weddell Sea, very close to the peninsula, and yeah, it was awesome.
We have a very important question here. You're a sailor. You've been in multiple cruises. Does a person with so much time in the ocean get seasick?
I have to say that I don't get seasick that much in the ocean. I do in a car, which is kind of crazy. Yeah, but in the ocean, well, it depends on how long is your journey, but you can get used to it. I think that it's really psychological. So there is a lot of people that gets dizzy and then start thinking of getting dizzy, and then even before going on a boat, they are already dizzy. But at the same time, you need to know how to deal with it. So there are some topical stuff like it's bad if you eat. For me, it's the opposite. Like, well, if you are super full, is you feel horrible. If you have something in your stomach, it's better seated. But if it's more placed, always, having like ginger and apple helps a lot, like acidic things. And yeah, there are some tricks. I think I have
Yeah.
never puked in a boat. Well, only once in Esperides, but it was because it was a huge storm. And actually, I didn't. I was having my lunch, and then the Sperides restaurant, the Sperides
Canteen, maybe.
canteen is in the boat, so it moves a lot when there are waves. I was moving maybe 1.5 meters every
Spoonful.
Yeah, so I was just like overfloated. Like, yeah,
wow.
everything went away. I was not even like feeling like I'm sick. It was just like on one of these going downs, it just everything like came out.
Yeah, that's physics.
it's
At the end of the day, it's not really puking or
No,
anything.
no.
No. It doesn't count.
I will take those tricks because I also get seasick, especially when the boat is stopped and with the waves.
Yeah, you need to look far beyond and then relax. Just think that you are not dizzy.
We would like to learn more about how is the food in the ships, and in terms of you when you are in a boat, if you can choose your bedroom, especially in terms of noise, engines, snores.
I'm afraid that you can't. Well, at least as a scientist, I didn't have the chance. In the oceanographic boats I've been, they are all they are ruled by the Spanish army. So they are military boats, at least the staff, let's say, the sailors are militaries. Of course, there you have like a sharp regime, let's say, like you have your schedule for having lunch and supper and so on. The food is not a menu, an open menu, so you have what you have. But it is true that taking into account the conditions and the logistics, they are quite good. It is also true that I can eat stones. I'm not maybe the best one for giving an opinion on that. In the last cruise, in the French one, it was awesome. It was French cuisine. And also the cookers were from Philippines and Indonesia. So there were a lot of Asiatic food, which I love. So in that boat, I really had very, very good food.
Actually, I think that fishermen, especially, they are really exquisite with the food. So
Yeah, that's it. Like people in the sea wants to have good meals because, of course, your energy and your mood it's affected by that. If you are all day long eating just I don't know porridge, maybe it's yeah. Also, is you have to think that mental health is really important also when you are isolated on a boat or you're on a long cruise. So I think that every little detail counts, and if you can have nice food or nice atmosphere while eating, I think that that would really help you. And that's something that is normally taken into account.
Well, I'm not quite sure how long these expeditions take, but I understand that maybe spending 24 hours in a boat can be maybe overwhelming.
Yeah, absolutely. Like the longest I've been, it was like a bit more than 1 month, maybe 1 month and a week or something like that. And then maybe 1 week in land and then another 1 month on board. So yeah, it gets long. Living on a boat for such a long time is like a big brother. It's like everything is super magnified. All the relations are super magnified. Like you hate, you hate, you love, you love. So there are huge stories behind what happens on a boat stays on a boat. And the thing is that you really need to have clear what you're doing. I mean, is it a job? Is it well? It may become your life. Like there's people that lives in cruises for a long, long time. But at the end, yeah, you need to be happy what you're doing. You need to be motivated, especially if you are a research scientist. You need to be motivated that your work is going to be good, that your samples are or your experiments are running well. So yeah, it's super important. Also, creating a nice atmosphere inside of these isolated places is super important, which is not always the case. So yeah, I really recommend if anyone is going to jump on a boat to think before like, okay, this is going to be just for this period and it's going to be a great part of my life. And if it's not, I will go over it. Okay, so it's just like a little break inside of your full life.
Quite interesting to know about that since, well, at least for me, the maximum time I've spent on a boat was maybe an hour in my life. We're going to move a little bit into science divulgation. We know you're very active in this field. This is an example. You accepted to join us here today. So yeah, we would want to know why is it important for you to well, is it important for you? And if it is, why is it important for you to communicate science?
Yeah, I don't remember who said, but science is not science until it's communicated because it's just a secret then, I guess. So I think that is super important, not only that we say what we do, but we include society in what we do. Because, of course, we are doing science because we love it, because we want to protect the environment or to protect people, let's say, but also because people deserve to be protected or the planet deserves to be protected. Okay, so if people is worried about if their drinking water is healthy or not, we should be there to help them. If people is worried because maybe there are going to be fires in their villages this very hot and dry summer, we should do something about it. Or if there is some water rising or whatever, no? So I think that for outreach, there has been in the last maybe 10 years a boom. So a lot of projects now ask compulsory for outreaching, for having, I don't know, a Twitter account or making videos or being on the radio. It's like compulsory. But at the same time, communication is bidirectional, right? So we cannot not only provide info to people, we need to get feedback and we need also to respond their demands. Okay, so a new phase of this outreach, at least for me, is also getting in community with our science, not only, okay, I'm going to do a talk. So,
you mentioned some keywords, which is communication or community, involving them. There is a concept, citizen science or community science. What's the difference between divulgation and community science?
yeah, it's exactly that. Like when you do divulgation, it's just like monodirectional message. So you just deliver your results, your project, your plans. But when you do community science or social or citizen science, is when the citizenship is involved into the research procedures. So, for instance, we have a new project. Maybe I'm seeing this coming. There is a new project that we have been for already 2 years developing in the Marine Station of Plencia for involving people in the Basque Country, in the Basque Coast, to analyze and, well, to know better first, and then to analyze biodiversity, microbiodiversity, and micropollution in the sandy beaches. So they, well, here in the Basque Country, people love the sea, I guess. They go a lot to the beach, but they don't know what's in the beach in reality. So all these microscopic pollutants like microplastic or microscopic living organisms such as algae or meiofauna, they are not known. And we took this nice idea of the hidden pollution and the hidden biodiversity to the hidden society. Groups that normally are not included in outreach, that would be potentially high schools or general public on a library, but we have gone a little bit farther. So we were working with inclusive groups, such as people in risk of exclusion or people with disabilities, people with mental disabilities as well, and many different volunteering groups in order to teach them how to look for these microbiota and microplastics. So it has been an awesome project so far. We had very good feedback from them, and they are actually building a huge database with all these observations. So they are doing the research themselves.
Careful, don't stand on me.
Exactly.
I believe that is the name of the project. Yeah, I actually had the pleasure to attend last year's final event, which took place in the Vizcaya Aretoa. Or is that correctly said, Xabi? The past translator. It was quite amazing seeing so many youngsters, well, actually adolescent people, having an interest in a little bit of what's going on around on the beaches. I also understand you're going to be doing this project for another year, for a third consecutive year, so congratulations about that. How can you contribute as a researcher to these type of projects?
Well, in this project, we are a 10 people team. It has changed slightly since the beginning. We had some people at the beginning and the first year, and then some new people in the second, and we have also more new people on the third. And each of us has different roles. Let's say the aim was to join a very multidisciplinary team. So we have people from chemistry background, biology, also engineering, computer science. So each of us has something to add. At the same time, we learn a lot ourselves when working, especially with the inclusive groups, because of course, most of the responsible people from these groups are or psychologists or social science, social workers, people were different types of educators. Our role is just to put science on as you said before, in a community, right? So I wouldn't say that I have like a fixed role. I would say like all in the team work on different aspects, but we all go, maybe we have all done teaching initial part. Also, we go to the beach with them sometimes. Also, we help them to do the analysis. Also, we do all the outreaching. We go to the radio or television to explain what we are doing. So yeah, there are many different things to do inside of the project.
Make sure that if you would like to know more about the project, search for the webpage, which we will be putting a link into.
Atención, no me aplastes.
Yes.
In Spanish.
We want to know maybe a book or a scientific paper you would like to recommend. Or
I don't know if it's very pretentious,
yeah.
but I would recommend one. I'm very proud of. It's a tale. It's a illustrated tale I wrote together with a colleague from Barcelona. It's based on actually you can read the original paper. It's a nature geoscience paper that was in my thesis. The tale explains how bacteria are helping us to solve the hydrocarbons pollution in the open ocean. The tale is called a Toxic Friendship. Yeah, a Toxic Friendship.
I like the name very much.
And it's about this little and tiny bacteria that lives alone in the open ocean. And then there are a lot of pHs which are like I don't remember the translation in English, but they are the hysteric friends. And then she has a very toxic friendship with them. And I'm not going to say the end. It belongs to a collection called, well, it's edited by Marum, which is a German research center for marine environment. Is Eras una vez, it's called in Spanish. I don't remember now in English. This particularly was illustrated by a student from here, from the University of Basque Country, from the scientific illustration master. So it's also kind of a great thing because it puts together real research with tales, with illustration from the university. So it's kind of nice. And another paper, I don't know, I recently read one that I really enjoyed, and it's about perfluorinated compounds, surface and groundwater. So it's about the misconception, well, not misconception, but underestimation of PFAS occurrence in our potential drinking waters. It's also a nature geoscience. I don't remember now the author, but I will give you it. It was very interesting to figure out how these pollutants are there, and maybe we are drinking them all the time. So yeah, it could be interesting as starting to know these fluorinated substances that I love that much.
Very nice.
I think you had a double chance to promote your things.
Yes.
To finish, we would like to introduce a question that we are interested on doing to every guest. It's an open question, and you are free to focus on something. The question is if, in your opinion, the work as a researcher is well valued or appreciated. You can focus in terms of salary, socially, governments.
Well, as a researcher looking for a permanent position since 10 years, I have to say that no, my answer is that is not well valued. I think that in general we have an opinion that a scientist is someone that is super smart and it's like doing a lot of very interesting, difficult things. But even if reality is that we are only consistent people, like we are someone that is pushing and pushing and pushing and testing and until we find some results. It's not about being smarter or more stupid than any other person. It's just about wanting to know, curiosity. So in general, society see us as like they value us, but of course, it is not connected to the salary we get or the money that governments in general invest on science. We all know that we should be over 1% or even 2% of national dedication given to science, and we are maybe one order of magnitude lower or less. So, of course, depending on the country, it can be better, it can be worse. But yeah, in general, I guess that we really need to push a lot more for our work rights. I think that it's also connected to our general philosophy of life, I'm going to say, because we are really devoted to our job in general, but we forget that it is a job. So I don't see that in many other jobs. Like most of my friends are not scientists, and if they have an issue in their job, of course, it's important. But when I have an issue, or even not an issue, just an open question in my work, I sleep with it. Like
It's very hard to disconnect.
that's it, and that is why we don't push that much for. Well, maybe it's one of the reasons because we don't push that much for our labor rights or for our conditions or for earning more or getting more permanent positions, because we are distracted with other things like science that really occupies all our mind and our heart. So I think that, yeah, we should also take care of ourselves and of, as we were saying before, mental health is very important. Good working conditions are super important. So yeah, we need also to put feet on the ground sometimes, realize that, yeah, this is just a job.
With this, we have to come to an end to our very first episode. We're very happy that you've been here with us. I've really thoroughly enjoyed talking to you, and maybe in the future we could even have you back.
You are welcome to
Exactly.
come back. Whenever
I
you
would
want.
love. I feel so honored to be the first one.
Yeah. We would also want to thank you for helping us with the project. Yourself have also been open to participate with this since the very start, and it might be one of the reasons why we're doing this interview right now. So thanks for that. Thanks for being in the show, and thanks to you, all of our listeners.
Thanks to you for guys for putting this in motion.